The MILO Space Science Institute is dedicated to making deep space missions affordable, accessible, and with a really rapid turnaround. We want to do compelling science and meet all of those objectives. The hypothesis is that we can bring together a consortium of organizations, maybe some big, maybe some small, maybe some traditional players, and pull together a critical mass of folks who want to go to the same place, do the same kinds of science or technology demonstration or engineering assessment or whatever, and pull that mission together.
We have in our sights the vast research capability in space science that ASU has developed over the last several decades, and have established the MILO Space Science Institute in order to amplify and magnify the research capabilities of the fastest growing research university in the world, which is Arizona State University, as well as the world-renowned hardware development capabilities of Lockheed Martin. And the MILO Space Science Institute provides the capabilities to allow all of our members to work together.
The MILO Space Science Institute is a really compelling opportunity to try to approach deep space exploration, science, and planetary defense in a totally new way. So we invite you to join us as partners in the MILO Institute.
Hey, good morning, good afternoon, good evening, wherever you are. Welcome, and thanks for joining MILO Space Science Institute's webinar on the MILO model for affordable, sustainable deep space science. I'm Jim Bell, the Chief Scientist of the MILO Space Science Institute. I'm a professor in the School of Earth and Space Exploration at Arizona State University, and I'm the director of ASU's Space Technology and Science, or NewSpace, initiative. And it's just really exciting to be here with everybody today. Thank you for participating. Two quick notes to participants. The chat feature will be disabled, so please use the Q&A function at the bottom of your screen throughout the webinar to ask questions. We'll be screening for questions that you have, and we'll have some time to address them at the end. And secondly, any questions that we missed today will be answered in our follow-up communications. So with those introductory remarks aside, I'll start by introducing our speakers today. We have on the far side of my screen, Charlie Cockell is a professor of astrobiology at the University of Edinburgh. His interests are the study of life in extreme environments and applying this study to the study of habitability on other planetary bodies. He's been the principal investigator on a number of space experiments, including the BioRock experiment, which flew to the International Space Station just in August of last year to study the effects of gravity on biological mining of elements from lunar and Mars-like rocks. Pretty cool stuff. And then next is Gordon Osinski. Dr. Gordon Osinski is a professor and the Industrial Research Chair in Earth and Space Exploration in the Department of Earth Sciences at the University of Western Ontario in Canada. He's also the director of the Institute for Earth and Space Exploration at Western and the director of the Canadian Lunar Research Network. He's been involved in several past and ongoing exploration-related activities, and most recently, he's the principal investigator for the Canadian Space Agency's concept study for an integrated vision system for characterization of the lunar surface. And so we'll be hearing more about that. He's also co-eye on the PanCam instrument on the 2022 ExoMars mission to Mars. And Dr. Osinski is also involved in providing geology training to Canadian and US astronauts in support of the Artemis program. And finally, last but not least at all, is Lindsay Papsidero, is the Chief Technology Officer for GeoShare, which is a subsidiary of Lockheed Martin that develops new satellite and space businesses. She leads the technical team that turns customer mission statements into architectures, payload designs, and full satellite configurations. Lindsay leads the collaboration between Lockheed Martin and the MILO Institute, coordinating the mission architecture development and spacecraft design effort. So it's a pretty great panel of folks that we have here today. And you saw and heard in the introductory video, MILO, the MILO Space Science Institute, is a nonprofit research collaboration that's led by Arizona State University with support from Lockheed Martin and GeoShare, which is a subsidiary of Lockheed. MILO was founded in 2018 to enable more scientists, engineers, students, and others, including those with little current experience or access, to be able to design, develop, and conduct deep space robotic missions with high science return. As many people know, there's much more deep space science that needs to be done than is currently being done by the world space agencies. Something like 9 out of 10 mission and instrument proposals for deep space missions and instruments are rejected, even though most of those are really good. There's just not enough resources. So MILO has a goal of building a global consortium of members to self-fund science-focused deep space missions for a fraction of the total mission cost for each member. So through membership, you'd have access to and share ASU, Lockheed, and GeoShare's expertise and infrastructure, with our goal being to help each member's local space science and engineering workforce development. Inaugural missions include studies of near-Earth objects and lunar missions. And in fact, the first mission that's so far farthest along in the planning phase is called Lunar Ride. And I'd like to pass it over to Lindsay now for more details on LunaRide and the other MILO mission concepts. Take it away, Lindsay.
Thanks, Jim. So Lunar Ride, as Jim mentioned, is our most active mission, the most far along in planning, and the first one we hope to actually launch with the MILO Institute. And so Lunar Ride leverages the collaboration between the MILO Institute and Lockheed Martin. And so it takes advantage of the Lockheed Martin Commercial Lunar Payload Services Program. So MILO members have access to the Lockheed McCandless Lunar Lander in terms of access to lander volume, power, data, and telemetry from that lander. Member payloads are delivered to Lockheed Martin for final integration to the lander, launch, landing, and surface operations on the lunar surface. Between Lockheed and MILO, we're very excited about this Lunar Ride mission, and we're hoping to be able to have our first launch in the 2023 timeframe. So as Jim mentioned, we have a couple other mission concepts outside of Lunar Ride. So these are Apophis Pathfinder and NeoShare. Both are mission concepts to study near-Earth asteroids. So our Apophis Pathfinder mission would send 2 small sats to perform the first ever flyby of the potentially hazardous asteroid Apophis, well before its historic 2029 Earth encounter. And the goal here is that we could provide initial reconnaissance data from our mission to inform and influence the planning of a 2029 mission. And so our second near-Earth object mission, NeoShare, is pretty similar to Apophis Pathfinder in terms of the overall science and mission goals, except kind of on a larger scale. So rather than just 2 small sats into a dedicated NEO target, we would launch a cluster of 6 small sats. Each of them would perform their own individual flyby of a different NEO target, and some could even reach more than just 1 NEO target. So in total, we would expect and hope to be able to characterize up to 9 different NEOs, which would be amazing and fantastic. So Jim, as you mentioned, the goal for each of these missions, any MILO mission, is to conduct deep space robotic missions with high science return. Thanks.
Cool, absolutely. Thank you, Lindsay. That's it's a great set of inaugural missions that the Institute's put together. So looking forward to doing all of them, but we're going to spend much of the rest of the time in this webinar talking about Lunar Ride in particular. And we, at the Institute level, we've had a number of conversations with folks from around the world about this opportunity. And specifically, we've brought 2 representatives of those groups here today. And talking with Oz and Charlie, MILO really became intrigued about learning more about their lunar payload concepts, the kinds of things they want to send and do on the moon, and for that potential collaboration then with MILO to make that a reality. So let's talk about that a little bit more with each of you, and we'll start by asking, and Charlie, you can go first. Just tell us a little bit more about your own personal interest and your group's interest in planetary science, and specifically focused on the moon.
Yeah, thanks a lot, Jim. So my group is really interested in microbes in extreme environments, whether they're microbes deep underground or microbes in asteroid craters or volcanic environments. And we're interested in those because we can learn a lot about the limits of life on Earth, but it also tells us about the habitability of other planets. But there's another aspect to microbiology as well. Microbes can do useful things. We use them to make our yogurt and our drugs and so on and so forth. And as we go out into space, we will also use microbes to do useful things. So as you said in your introduction, our most recent experiment was an experiment we flew to the International Space Station last August to see how microbes grow in simulated Martian gravity and microgravity on pieces of that they can be used for. We want to do the same thing on the moon as well.
Very cool. And maybe the same question to you, Oz. What's your own background in planetary science, interests in you and your research group, and especially focused on the lunar opportunity?
Yeah, so it's great to be here, just like Charlie said. And so I'm a geologist by background. My personal interests focused on impact cratering processes, products on the moon. I do a lot of study of Apollo samples, remote sensing. I'm interested in the broad origin and evolution of the moon, but also increasingly in situ resource utilization. What resources are there on the moon too? I also have a keen interest, in how we're going to go about exploring the moon in the next few decades. So as you said, providing geology training for astronauts, and I conduct a lot of robotic analog missions to learn how best to explore the moon. With my institute director hat on here at Western, we also have faculty who are interested in doing astronomy either from the surface or around the moon, robotics, artificial intelligence, machine learning, and space health too.
Very cool, good stuff. So let's talk a little bit more about the opportunities that both you and your colleagues are pursuing, potentially with MILO in terms of the specific payloads and experiments and hope for science that you want to get out of the LunaRide opportunity. And we'll start with Charlie with the group at Edinburgh.
Yeah, sure. So one of the questions we want to address on the moon is, what is the fate of biological molecules on the moon? So when we go to the moon, whether with robotic craft or humans, we will inevitably contaminate the surface with microbes and other sorts of biological material. And we're really interested in knowing what the fate of that is. For example, one of the things that people might want to do on the moon is collect ancient asteroidal material, ancient ices in, for example, permanently shadowed craters, to try and learn something about the sorts of molecules, organic molecules, that might have been delivered to the early Earth, the sort of inventory of organic molecules that may have provided perhaps the building blocks for the origin of life. And we don't really want that material getting contaminated with bacteria and all that biology we take with us to the moon. So what does happen to biology when you take it to the moon? And what we're proposing is a payload to investigate the fate of microbes and their constituent biomolecules like lipids and nucleic acids and carbohydrates in the lunar environment. How does that thermal regime and radiation regime in the lunar environment change the fate of microbes? And not only that, we can learn something about how the radiation environment in space will affect microbes that might be being used in life support systems or in industrial processes. How can we do useful things with microbes on the moon and have them grow properly in that relatively harsh lunar environment, even if they're inside a habitat?
Very cool. All right. And same question to you, Oz. Tell us a little bit more about the payload concept that you're pursuing with MILO and the kinds of science that you're hoping to do on the moon with that payload.
Absolutely. So you mentioned this integrated vision system concept earlier on, and the science questions we're looking at are much broader than Charlie's. With this setup and with this vision system, you could look at impact cratering, volcanism, nature of the regolith, volatiles, really all aimed again at understanding the origin and evolution of the moon and preparing for long-term human presence. And so it's cunningly called the integrated vision system. It combines an ultraviolet, visible, near-infrared spectrometer with a short wavelength infrared spectrometer, and then a multi-wavelength LiDAR into kind of one vision sensor head. And with this, you'd be able to characterize the texture and composition of the regolith, of rocks, of boulders, of samples you collect, create 3D digital terrain models that you could put into a VR headset to use not just for science, but for rover navigation and hazard avoidance too. And thanks to the LiDAR, which is an active sensor, you'll be able to look into permanently shadowed zones. So, we're also interested in volatiles like Charlie is, and potentially even, detecting them and understanding the composition of those permanently shadowed zones. And so for this initial kind of partnership with MILO, we're really excited. We're kind of calling it the not so integrated vision system. The full IVS is really beyond the time frame and the time that we're working towards and the budget that is available. So we're looking right now to fly a component, some subsystem of this on this early LunaRide mission.
Very cool, very cool. Let me ask both of you this question. Let's assume you get on board, you come together as MILO members, we get this payload opportunity on the Lockheed McCandless lander. LunaRide happens, and the experiment is a great success. What do you see as the follow-on? What is this enabling? This opportunity from MILO? What's it enabling for the kind of science you want to do? And we'll start with Charlie.
Yeah, so our BioCubes concept for the LunaRide is going to be very simple to begin with. On the first lander, no power, no telemetry, just microbes in a specified cube that we're designing that will look at the fate of these molecules. But we have big ambitions. We want to be able to actively grow microbes in the lunar surface. So the BioCubes concept, as we currently plan to fly it, will be essentially, as I say, dried microorganisms. But of course, to do useful things on the moon, like whether it's making drugs or growing biofilms to make food or whatever it is, will require microbes to be growing. So the next iteration will be to look at those microbes in real time, adding things like microscopes to our payload, and then eventually growing microbes in the lunar environment to study their genetics and physiology. In fact, quite similar to what we did on Space Station last year, essentially taking that hardware, automating it, getting it onto the lunar surface, and being able to really study the biochemistry and molecular biology of how microbes grow in the lunar surface, how we can improve their growth, and then begin to target them towards more industrial processes. So this first stage in landing on the moon with the LunaRide is really our first step in demonstrating our capacity to do a biology experiment on the moon. And then following on from that, we have much more ambitious goals that will lead to full-scale little miniature vessels, if you like, to grow microbes on the lunar surface, what we call bioreactors, so small miniature vessels for growing microbes.
Very cool. Nice. Thank you. And same question for you, Oz. Where's this going to lead? What is the MILO and LunaRide opportunity enabling for your science and your research group?
Yeah, for sure. Like Charlie, this is going to be a really critical first step for us in demonstrating capacity. This would be a first, not just for Western, but for Canada. This would be, if it comes to fruition, the first Canadian scientific payload on the surface of the moon. And so, just achieving that, being successful in this first opportunity with, again, kind of part or a subsystem of this integrated vision system, will allow us to then, build and take that further. And, our goal is that then this kind of complete integrated vision system will maybe fly on, every rover that goes to the moon. It could be used on robotic and human rovers. And again, with so many science applications, we're hoping that, there's people even out there on this webinar that might be interested in this and partnering and, potentially using the data in the future.
Cool. I'm going to try to squeeze in one more question for both of you before we turn it over to Q&A from the participants. And that is, so why MILO? Where did, what made you choose to get involved with MILO? What is MILO offering that, why MILO? ? And start with Charlie.
Yeah, when I flew my experiment to Space Station last year, I wrote that proposal in 2009. It took me 10 years from writing the proposal to actually getting an experiment that ran for 3 weeks on the International Space Station. And that's just the past reality of launching scientific experiments into space. So this whole new space vision that's encapsulated by MILO's philosophy is just tremendously exciting. The fact that we began our conversation, a few months ago, and now we're having a serious discussion about putting a payload on the moon. This is a totally new paradigm. It opens up hugely new, exciting possibilities for scientific exploration. Most importantly, as a scientist, it means that we can start to really plan these experiments on a regular basis. We're not waiting for 10 years to do one experiment. We can really start thinking about follow-on lunar experiments that build on LunaRide, which means that we can really have a consistent research program in life sciences, biological sciences on the moon that can be run by an individual research group. That's a totally different way of doing things. And one of the reasons why we're really excited about working with the MILO Institute.
Awesome. Same question to you, Oz.
Well, I mean, I think Charlie answered it beautifully and encapsulated kind of, you know, why we're excited to be a partner too. Again, it was really just last November that, you know, the MILO Institute actually reached out to me, and we met during the International Astronautical Congress in Washington, D.C. And yeah, the time frame, I think the philosophy of the MILO Institute is wonderful. You know, it's very noble and really sharing the expertise that you've built at ASU and at Lockheed Martin with, you know, like you said, big groups, soul groups, big companies. You know, here in Canada, we do have a lot of space heritage and space history, but being able to partner with MILO, getting our foot in the door and potentially missions to the moon is just, yeah, really exciting. And, you know, bringing your expertise to the table is hopefully going to let us achieve that.
Sweet. This is when we started this a number of years ago. This is exactly the conversation that we were hoping to have and kind of things we were hoping to hear. Lindsay, I know you've been screening the Q&A coming in. You want to throw some questions to our panelists?
Yes, I would be more than happy to. So the first question that came in is, if our payload is not ready to fly on the LunaRide mission, can we still participate?
I vote for Lindsay to answer that question.
Sure, be happy to. So I do want to mention, you know, I threw out the date of hopefully our first LunaRide mission going in 2023, but I want to explain that that's not the only LunaRide mission. So we ideally through the CLIPS program, the idea is to have, you know, 1 to 2 lunar landing opportunities a year. So we would like to, you know, be able to do a couple of these LunaRide missions at a pretty frequent cadence. So if you're not ready in 2023, maybe you're ready in 2025. We would love to continue talking with you, shaping it, maturing it with you however we can. Or if you want to participate in a different way and maybe it's not a flight ready payload to go on the lander for the 2023 mission, again, we're still very happy to have you and we would love to have those conversations with you. Do you have anything to add to that, Jim? Or
no, I think it's a brilliant answer. Absolutely. Perfect.
Great.
Yeah.
Okay.
Any more?
Yeah.
Oh,
so I have
cool.
another question, which is, how do I join MILO and get more information?
Oh, that's a great question.
I'll let you answer that one.
That's a great question. Well, you talked to us. You've already reached out by participating in or watching this webinar. MILOinstitute.org is our website. We'll be following up this webinar to those who registered with additional contact email information for our leadership team: David Thomas, our executive director, Lindsay, myself, Lon Levin from GeoShare, Scott Smash from ASU, others involved in this. You may remember the time when we could go to conferences. Back in those days, we, as Oz pointed out, we attend IAC, the COSPAR, you know, the Space Symposium. There are MILO representatives that go to these meetings to reach out to the community. But really, it's about reaching out, having an initial conversation. MILO is a science-focused organization. We want to enable much more deep space science to be done than is getting done. And you know, lots of folks have ambitions in terms of science, but they can't compete for large mission opportunities because they don't have the experience, or it's just incredibly competitive. There are just so few opportunities. So if you have ideas, and we have a science council within MILO, consisting of a number of folks from ASU, University of Arizona, Northern Arizona University, other places around the country, around the world. And as a MILO member, your organization will get a seat on that science council. So you can be involved in making decisions. For example, if we fly the NeoShare mission, which objects do we visit? You know, at any opportunity we could launch that mission, there are 100 near-Earth objects that we could fly by. Which ones, which color classes and sizes and compositions, you know, it's really up to MILO members to build that mission because it's a consortium. So it's really, the answer is reach out, let's have a conversation, let's get on the phone, let's do email, let's do video conference, let's hear about what you want to do and how we can make it happen within the MILO model.
Great, thanks. So I got a couple more. I'll do one that's just a logistics question, and then we'll jump into some other questions. But we got the question of if this session will be recorded and available later for folks to watch who are not able to make it. And that answer is yes. We will be sending out a link with the recording after this. So thank you. So next question is, and everyone feel free to jump in to answer this, especially because we have an international group on the phone today. What are the biggest programmatic and political risks with this new paradigm of space science exploration?
Which one of our international colleagues wants to
take
that?
I'll take a crack at that. Well, you know, obviously, first of all, I'd say the benefits outweigh the risks. I mean, the opportunity to work with MILO to put a payload on the moon means that, you know, any national political risks, I think, are fairly minor. They're things you want to sort out. Of course, the risk always with doing these things is finding the funding to build the payload. And often that's a level of funding. I mean, our payload, our BioCube's payload is going to be very, very small, about 10 grams. But when we move on to bigger payloads that we plan to do, we'll be in the realms of funding where we need to try and get national funding. So that does require buy-in from national space agencies, and they have to have a strategy that includes, for example, lunar exploration. So those are the sorts of risks that you face as you start to build a program. You need that buy-in. But having said that, these sorts of opportunities in many ways are help break down these risks in the first place. If you have an opportunity and there's a real possibility of putting, for example, in our case, a UK payload on the surface of the moon, I think we're in a very strong position to try and break down risks and make it happen. So I think the risks are very minimal. I think the opportunities are quite staggering, really.
Yeah, I mean, I obviously agree with you. And in a sense, it's a similar model in some ways, smaller scale, as the European Space Agency, right? I mean, that's a consortium of nations. They build membership essentially through, you know, paying dues essentially to a central organization and that enables billion-dollar, multi-billion-dollar class missions to happen. But there's always a risk there that certain, you know, members of that consortium might not be able to come through.
So what's beautiful about this is that we don't, you know, because it's not going through conventional space agencies, the notion that as a University of Edinburgh, we can essentially pay to put something on the moon. I mean, that's obviously the paradigm of new space. And that opens up whole new possibilities of simply developing payloads in the same way you would send an experiment, I don't know, off to Antarctica or something. You can pay to send it there, you can pay to send your payload to the moon. That was a paradigm that was never possible when one had to go through these very long-winded methods of working purely through space agencies. I mean, not that that's a bad thing, but that was the only route before of doing these sorts of things.
Sure, and it's important to point out we're not competing with NASA or ESA or JAXA. I mean, our goal is to augment, is to try to fill in, choose from the large list of missions that aren't getting done because the world's space agencies just don't have the resources to do it all. So that's where MILO can fit in. Anything you want to add to that, Oz or Lindsay?
You know, I would say, yeah, like Charlie said, you know, the benefits outweigh the risks. I think there are a few political risks involved in this, you know, and programmatically, you know, Canada doesn't have its own launch capabilities. So, you know, I don't really see this as much different to how we've operated for the past, you know, 40, 50 years, where, you know, if Canada wants to send up an Earth observation satellite, you know, it could be the $1 billion radar sat type satellite. We have to put that on somebody else's rocket and rely, you know, on either on that company or that nation. And so I think, you know, this is I think in Canada, we're fairly used to this type of model. It is a bit differently, as Charlie says, where we could be doing this at the institutional level now too. And so,
very good.
Yeah, again, benefits definitely outweigh the risks.
Cool. Well, we are winding down here, running out of time. Let me just make a few quick closing remarks. First of all, thank you Lindsay, Charlie for joining us. Thank you to the participants who have joined in a big number. This is awesome. We've tried to predict in the promotion for this, what will space science look like a decade from now? And the answer to MILO is that it'll be much more diverse and much more accessible, that there'll be many more missions possible using models like MILO Space Science Institute. So keep in mind, if you're interested in joining with MILO or contacting us, there's a new decadal survey coming out soon in Planetary Science that'll try to rank all the important science to do in the solar system. That will include missions and instruments and science investigation for those missions. So there'll be great resources to kind of back up your own group's scientific interests. And also just a final logistical note that there are a number of questions that came in we couldn't get to. We'll do our best to answer each question today, and we'll post responses on our follow-up communications after the webinar. So thank you again to our panelists. Let's do a little virtual clap, clap. Thank you for joining us. Thank you, participants. And to learn more about MILO, miloinstitute.org is a one-stop shop to get that initial information. Please reach out, contact us. Please consider joining the MILO Space Science Institute. Thank you.